Hello, algebra students. Mr. Lawrence here. We're going to be trying to decide which one would be better to use, substitution or elimination, and then solving it. So I've got 6 example problems here, and what I'd like you to do is, as I talk about each one, pause it, decide which way you want to solve it, go ahead and solve it, and then watch and see if I do it the same way. Now, note, just because you might pick a different way than me, doesn't mean you're wrong. It doesn't mean you can't get the right answer. Make sure that whichever way you pick, you do get the answer that I get. Okay, so problem number 1, the blue equations, the blue system, 3y equals 14x minus 9, and y equals 9x. I'd like you to pause, decide which way you want to solve it on your own, and then check my solution. All right, here comes my solution. Since y is already alone in the second equation, I'm going to do some substitution. I'm going to write 3 times the quantity of 9x plus 10. That's going to equal 14x minus 9. Distributing the 3 will give me 27x plus 30, and that'll equal 14x minus 9. I'm going to get all my x's on one side and all my constants on the other, so I'm going to subtract 14x 2 places. Then I'm going to subtract 30 in both places. And my new equation is going to be 13x, which is going to be equal to negative 39. Divided by 13, I'll get that x is negative 3. Now that I know x is negative 3, I'm going to substitute it in. I think I'll put it right in here. I'm going to get y equals 9 times negative 3 plus 10. And so then y is going to equal negative 27 plus 10, which is negative 17. And therefore, the lines will cross at negative 3, negative 17. I chose to do it by substitution because the y was already alone. It would not have been that difficult to multiply the bottom equation by negative 3 and solve it from there either, though. That would be a good way to do it. All right, number 2, the black equation. I think I'm going to do this by elimination. I'm going to multiply the bottom equation by negative 1. And what that's going to get me, the top equation will be x plus y equals 4. And then the bottom equation will get me negative x minus y, and that'll equal 4 also. When I add them together, my x's are going to cancel, my y's are going to cancel. Please don't say there's nothing left. Please say getting 0 on the left-hand side, and then 8. Hey, wait a minute, can 0 equal 8? No, 0 cannot equal 8. This system has no solution. Now think about it for a minute. What system of 2 linear equations would have no solution? 2 lines that are parallel. Remember, we're trying to find a place where they cross. These 2 lines cannot cross. By the way, I could have known that right in the beginning if I would have checked the slopes. If I would have done the negative a over b shortcut for the first equation, I would have gotten negative 1 over 1. Then for the second equation, a is 1, b is 1, I would have got negative 1 over 1. I got the same slope. The lines are parallel. They don't cross. All right, number 3. Think about which way you would want to do this one. Well, before I decide, I'm actually going to write the equations both in standard form. My top equation is going to be 3x minus y equals 8. My bottom equation is going to be negative x. Hold on a second. I just saw something I think would be easier. You know what I'm going to do? I'm actually going to do it by substitution. I'm going to solve for y in this top equation, because that's easy to see that 3x minus 8 will equal y. I subtracted 8 from each side. Now that I know that, I can do 3 times the quantity of 3x minus 8, and that'll equal x plus 8. Distributing, I'll get 9x minus 24 equals x plus 8. I'll subtract x from both sides. I'll add 24 to both sides. And I will get, see, those will cancel, 8x on the left. Right hand side is going to be 32. X must equal 4. All right. Now, since x is 4, I think I'll plug it into the first equation. Actually, the green one here. The green version of the first equation. I'll get 3 times 4 minus 8 equals y. That's 12 minus 8 is 4. It means y is 4 as well. These two lines intersect at the point 4, 4. I initially was going to do it by putting them both in standard form and then doing some form of elimination. And I thought, geez, it might be a lot simpler to just go ahead and do it by substitution. Now, number 4, go ahead and think about how you would like to do it. Here comes my ideas. I'm thinking, oh, I could multiply the bottom equation by -5. That would work pretty well. Or I could solve for y in the top equation. I think I'm going to do it by elimination. I'm going to multiply the bottom equation by -5. And really right now, I don't have a great reason for that. Something from my past experiences telling me this is a good one to do that for. So my top equation is still 10x plus y equals 12. But my bottom equation turns into -10x plus 50y, and that's going to equal positive 20. Am I doing this right? I think I am. I don't think it's coming out very pretty, but that's okay. It doesn't have to. I'm going to get 51y, which is going to equal 32. And if I divide by 51, ooh, this is an ugly answer. I don't think that simplifies. 3 and 17 don't go into 32, so y coordinate is going to be 32 51st. So I'm just going to double check my math here. -10, right? Positive 50, and positive 20, and then cancel 51. Yeah, looks like my math is good. All right, this is an ugly answer, but I'm not afraid of it. So I'm going to substitute that 32 51st into the first equation. I'm going to get 10x plus 32 over 51 equals 12. All right, so I'll subtract 32 over 51 from both sides. And I'm going to get 10x, and that's going to equal, well, if I was taking half away, it's going to be 11 and a half. So I'm actually going to get 11. And let me see, how far is 32 from 51? Looks like it's 19 away. 19 51st. Oh my goodness, this is an ugly answer, but that's okay. Good to see an ugly one every now and then. I'm going to cut off my work here. I'm going to convert that mixed number into a improper fraction. So 51 times 11 would be 561, if you remember the trick I've shown some of you. And 561 plus 19 looks like it's going to be 580, right? So I'm going to get 580 over 51. Then I'm going to divide both sides by 10, which will be the same as multiplying the right-hand side by 1 over 10. And here's why I did that. 10 can go into 580 58 times, so x is going to equal 58 51st, which is the same as 1 and 7 51st. So the place that these two lines cross, the x-coordinate is at 1 and 7 51st, and the y-coordinate is at 11 and 19 51st. And that was an exceptionally ugly problem, but it's good to see that every now and then. All right, number 5. Go ahead and decide how you would solve it. I'm going to do it by substitution, but first I'm going to multiply through by -1, which changes all three signs. I'm going to rewrite my second equation, substituting in negative 3x plus 1 for y. And that's going to equal 3. All I did was take this and put it in for y right there. All right, I'm going to get 9x minus 9x plus 3 equals 3. And in this one, the 9x's are going to cancel, leaving me with 3 equal to 3. Well, when is that true? That's always true. This is one of those situations where you're thinking all real numbers. Now, because we're dealing with two different lines, you have to stop and consider it's not actually going to be all real numbers, but there are going to be infinitely many solutions. And the reason is, does anybody know? They're actually the same line. If you were to graph both lines, you would find that they are the same. Here, let me prove that to you for 1 second. I got y equals negative 3x plus 1 for the first equation, right? The slope is negative 3. The y-intercept is positive 1. Now in the second equation, we have 9x plus 3y equals 3. The slope is going to be negative a over b, or negative 9 over 3, which simplifies to negative 3. They have the same slope, right? The y-intercept is c over b, which is 1. If we have the same y-intercept and the same slope, don't they have to be the same line? Right, so we say this system has infinitely many solutions. All right, last one. Go ahead and decide how you would solve it. Here comes my solution. I think I'm going to go ahead and do substitution. I'm going to take that top equation. I'm going to add x to both sides. I'm also going to subtract 1 from both sides. So the top equation is going to become x equals 19y minus 1. I'm going to rewrite the second equation as 3 times the quantity of 19y minus 1. I lost my place, and there will be a minus 1, and that'll equal 5y. There we go. Distributing 19 times 3 should be 57y minus 3 minus 1 equals 5y, right? That's a y there. Oh my goodness, I picked another ugly, ugly problem here. All right, going to combine like terms, and these will turn into negative 4. So I've got 57y minus 4, which will equal 5y. I'm going to add 4 to both sides. Also going to subtract 5y from both sides. I'm going to get 52y, and that's going to equal 4. Divide by 52, divide by 52, and I think y is going to end up being 1/13. Pretty sure about that. All right, so now I know y is 1/13. I'm thinking that they're all really ugly. I'm thinking I'm going to plug that in here and see if I can't solve for it. So let's see here. 3x minus 1 equals 5y. So I've got 3x minus 1 equals 5 1 times 1 over 13. For 3x minus 1 equals 5/13. I'm going to add 1 to each side, which would be the same as adding 13 over 13, wouldn't it? Okay, so I'm going to have 3x, and that's going to be equal to 18/13. I'm going to divide by 3, which is the same as multiplying by 1/3. Those will cancel. 3 will go into 18 6 times x will equal 6/13. Well, I guess that's not so bad. So the x-coordinate is 6/13, just less than a half. And the y-coordinate is 1/13, which is a pretty small amount. All right, there we go. All right, hopefully you are a master of deciding which form to use, substitution or elimination. Mr. Lawrence signing off. Good night, everybody.